Good morning, students. So today we study about the refraction of a light through a lens. So in previous lecture, we study about the refraction of a light through a glass slide. So basically, what is the refraction? So refraction is the phenomena when light going from one medium to another medium, it change its path. So these paths change due to the change in the velocity in the medium. So in previous lecture, we take a glass slide and light entering from air to glass slide. So air acts as a rare medium. So that medium which have low optical density, that is known as rare medium. And second medium, which medium what glass medium, so that glass medium acts as denser medium. So we also learn that when light going from rare to denser medium, it bend toward the normal, and when light going from denser to rare medium, it bend away the normal. So basically change of path of a light due to the changing the velocity of the light in the medium. So different type of the medium we can use, like air, water, and some chemical substance, some chemical oil, that is ethanol, methanol, alcohol, that is chemical substance. And we can use different type of materials, glass, and some materials are solids like diamond. So here how much rays are bent from original path, so it depend upon the refractive index of that materials. So refractive index of the air is very low, nearby 1.0003, and other materials like glass materials nearby we taken 1.5 and diamond 2.42. So that have higher refractive index as compared to the air. So when we compare the refractive index which have lower refractive index, we consider that medium is a rare medium, and which have high refractive index, so that materials have what is denser medium. So here we also study about the lenses. So what is lens? Lens are made of a transparent materials. So here we study what is refraction. Through a lens. So basically lens are two types, that what is what convex, and second concave. So these lenses are made of a transparent materials, made of transparent materials. Okay, so sometimes we call that convex lens is a double convex lens, that is and this we called double concave lens. So basically what is lens? Two types, what is convex and second what is concave, and these are what is double convex lens called, and this is double concave lens called, and what they are made of a transparent materials. Okay, so double convex lens means they contain two spherical surface. So that is why we call that double convex lens contain two spherical refracting surface. Okay, so we can understand with the example of a data lenses. So first we take a convex lens. So this is a convex lens. So this contains two refracting surface, one refracting surface this and second refracting surface this. So we make here, this is a first refracting surface. Okay, and this is second refracting surface. So this is first and this is second. So we take here center point. So this is the center point. This center point called O. So this is known O. So that this point is known as the optical center of the lens. So we write here optical center of lens. Okay, so here this is one sphere and this sphere consists a center. That center is known as what is center of sphere. So this is known as center of sphere C. So see here what is center of sphere. So here this is the center of a sphere of a lens of a sphere first. So we mark here this is C1. Okay, so we here mark this is C1. And here similar, this is the center of a sphere second. So we mark here. So this is what is C2. Okay. So if we draw a line that passing through the C1, O and C2, so that line is known as the principal axis. So we draw here line. Okay. So this line is known as the what is principal axis. So we mark here. Principal axis. So here one more important point, that is what is focus. So that is between half distance between the C1 and O1. So there is another point. So this point is known as F1. So what is here F1? F1 is the focus of a sphere 1. So we write here F1 focus of sphere 1. Okay, so similarly here another focus. So this is known as what is F2. So F2, this is sphere 1 and F2 focus of sphere 2. Okay. So C1, F1O and F2, C2. So we simply, here we can write this C1 double of a F1. So what is the relation? We already learned relation in mirror. What is the value of a R is equal to 2F. So what here R is the radius of curvature. Radius of curvature. So this is equal to R is equal to 2F. So this distance, this R is equal to 2F1. 2F. So here simply F1. So we write 2F1. So we can replace this C1 with what is 2F1. So we replace here this with what is 2F1. So similarly, this C2 replace what? 2F2. Okay, so here get we write here points in term of a f1 and 2f1 and f2 and 2f2 in term of a focal length. But in case of a mirror, we write there what is c1 and c center of curvature and focus f. So here we simply write in term of a focal length f1 and 2f1 in term of a focus. So we can replace all by so this is what f1, this is what 2f1, and this is f2, and this is what is 2f2. Okay, so this is a structure of a double convex lens. So they contain two spherical surface 1, that is sphere 1, and that is second spherical surface. So if we draw simply in term of a lens here, so we erase them. Okay, so here convex lens, what this is thin at the edge and thick at the bottom. So this here thin at the edge and thick at the bottom. So this is the characteristics of a convex lens, and we can find out by the touching if we having that type of a lens. So we find out by the sliding over fingers on the lens. So we observe that thick at the middle and thin at the edge. And this lens also known as what is converging lens. So converging lens is they converge all parallel beam of a light at a single point. So another name what? Converging lens. So this is known as converging lens. For example, when all parallel rays comes, they are focused at the point. So this is the structure of a first lens. We take another type of a example. So second type of a lens, what here we take a concave lens. So concave lens which are thick at the edge and thin at the middle. So we take example this. Okay. So this is at the thick at the edge and thin at the bottom. Thin at the middle, sorry. And here we take, this is a optical center, and draw here a principal line. So this is a principal line or a principal axis, and this also consists two sphere. So first sphere this. So this is a first sphere, and this is second sphere. So this first sphere consists a center that is known as C. So this C replaced by with what? 2F1. And this is a focus. So this replaced by F1. So F1 to F1, and this consists a sphere C, center of curvature C, and this is 2F2, and this is simply what? F2. Okay, so this type of lens known as what is diverging lens. So diverging lens simply they spread light in different direction. So how light converge and diverge through these lenses, so we can understood with the help of a diagram. So first of all, here we make this is a convex lens, okay, and this is a concave lens. So this is a center of lens O, and this is also a center of lens O. So draw here principal axis. So this is principal axis that passing through the center. Okay, and take this is F1 and this is 2F1 and this is F2 and this is 2F2. So similarly here, this is F1, this is 2F1 and this is F2 and this is 2F2. Okay, so this is what is convex lens. And this is concave lens. Okay, so we take here parallel rays. So these are rays which are coming parallel from the infinitive distance like this. Okay, so when they are passed through the prism, so they are refracted and they pass through the focus. So these are refracted and they change their path. So they change their path and passing through F2. So this is a here common point or common intersection, this point. Okay, so this is known as what is focus. So that is why we called this lens is a converging, because when all parallel beams come, so they pass through a common point. That common point is known as focus. So that is why this is known as the converging lens. And second, when ray comes parallel in concave lens like this, so what happened? They also refracted. And how they refracted? So they refracted like this. So here you can see clearly that these rays are going in different direction. So they are spread. So they are never meet at any point, but their image are formed at common point. So that common point is F1. So if you extend this image, so where they cut F1 like this, so this also, and this is same. So they form common point here. This common point is known as focus. Okay, so they form what here real and inverted image, and they form here what is virtual image. So that is, we already learned that real image, that image which cannot obtain on a screen, and virtual image, real image that can be obtained on a screen, and virtual image that can be does not obtained on a screen. Okay, so this is known as the diverging lens. What is this? Is diverging and this is converging lens. So next we learn about rule of the ray diagram. So how to make a diagram of a object, when object plays a different distance where the image forms. So there are the different rule. So first rule is, so we take here again so this is O and this is also O, and this is principal axis and this is also a principal axis. This is what is F2 and this is what is 2F2 and this is what is F1 and this is 2F1 and this is what is F1, F2 and this is 2F2 and this is what is F1 and this is what is 2F2. So first rule, when a parallel rays come, parallel rays means that comes parallel to the principal axis, so that always pass through the focus. So here we take, so this is parallel rays, so parallel rays to the principal axis, so it pass through the focus. So this is first rule. And second rule, when a rays come what in direction of a optical center, so that pass through the optical center. And third rule, when a ray comes in direction of a focus, so like they comes in a direction of a focus, so after the refraction they pass through parallel. What is parallel? So this is going in parallel direction. So similar things here. So when comes parallel rays, so it refracted and passed through the focus. And second things, when comes in the direction of an optical center, so they pass through straight without any refraction. And when comes in the direction of a focus like this, they comes in direction of a focus, though they pass through parallel. So these are the rule of a refraction of a lens. Thank you very much.